I'm Bob Plankers. I'm a senior technical marketing architect with VMware Corporation. I'd like to talk about designing vSphere environments, designing them with security and compliance in mind from the beginning. What do we need to think about? What do we need to do? We often think of design, building operations, things like that. We often classify them as day zero, day one, day two. I don't really like that classification because I think it pigeonholes a lot of security work, a lot of design work into certain areas where, in fact, we need to be flexible over time. But regardless, before we even get to day zero, any hardware gets to our data centers, before any of that gets built, what do we need to think about? So put this talk together to explore some of it. Let's go through it a little bit. This is our standard disclaimer. If I happen to wander into roadmap sorts of things, I'm not really planning on doing it, but if I happen to say something, don't be alarmed. We may change our mind at VMware. We do from time to time as we try to figure out what the best way to implement something is, the best way to build something. We're very cognizant of vSphere admin staff time, that sort of thing, and try to make life easy on folks. The other thing too, compliance. We're going to talk about compliance. If you're subject to compliance and regulatory needs, compliance frameworks, that sort of thing, your auditor has the final say. And I've got thoughts on that as well, but we can save those for another time. Check back with our YouTube channel here, and I'll talk more about that in the future. But, conversations with auditors, a lot of that is educational. We can educate ourselves. Auditors can educate us. We can educate them about vSphere capabilities and features. And so it's a two-way street. So anyhow, defer to your auditor, please. They have the final say in whether you pass or fail. So, yeah. Moving on, what is this talk? Let's talk about the talk. Very meta of me here. We'll talk about the baseline right away. What are the few concepts that we need to know right off the bat that color the way we think about compliance and security and system design? We'll talk about some of that stuff so that we get the ground rules out of the way. Then we'll talk about the beginnings of an actual system design. What do we need to know? Who are we building this for? That sort of thing. Hardware. Let's talk about hardware. We love saying that, use the cloud. The cloud is somebody else's computer, but that matters. That hardware matters. And even in the cloud, you can get underperforming hardware. You can get newer hardware, older hardware. Companies like Netflix have processes to test out, instantiate instances of their software, see if they're on newer hardware or not, and if they're on old hardware, shut it down. Hardware, we can make some decisions about hardware, both in the cloud and on premises that make things better performing, make things more flexible, give us options. If these environments are going to last 5 years, 7 years, hopefully not that long. Ideally, these environments last 3 years, but everyone's got different budgets. Everyone's got different tolerance for change, that sort of thing. And so, 5 years. In that 5 years, we're going to have different realities at the end of that 5 years than the beginning. One of the realities that we have right now, and we didn't really have 5 years ago, was ransomware, and we'll talk about that as well. Isolation. This is 2020, and I hate to bring it up, but isolation seems to be the theme of the year. That's true for a lot of stuff. Ransomware, security, creating checkpoints, control points, and that perimeter firewalls. We'll talk about a lot of that stuff. And availability. Turns out you can solve a lot of problems by patching, doing it in a timely fashion, that sort of thing. It's the only way to remove vulnerabilities from environments is to patch the vulnerability out. And it's an availability problem. Patching is just a small outage, right? Hopefully scheduled, but we do what we can. So what is this talk? This talk is not a system design. You're not going to leave this with a system design. What I'm hoping is that you leave with a few ideas about your system design, some things that you can improve, some things that you can improve in your current environment as well. You know, if you've deployed vSphere already, probably have if you're watching this. Thank you very much. Thanks for subscribing to our YouTube channel, by the way. Please do if you haven't. Click the subscribe button below. You know, I feel like a YouTube guy now. Hit the bell, you know, that sort of thing. But so it's not going to be a system design, but we're going to talk about a lot of different stuff, and I'm really hoping that you take a few things from it. That's my goal. So let's move on. Ground rules, baseline stuff here. The first thing I like talking about every time is that security is always a trade-off. You know, security is not something that you just do. You know, otherwise we would have products that are infinitely secure. You know, but you know the most secure environments are the ones that are shut off, that are turned off, locked away, completely unusable. And that's the trade-off. More security, less usability. That's a big trade-off. But we also trade budget. We trade staff time, which is really just a subcategory of budget. We trade administrator will to live. You know, everything and the usability. It's vSphere admin usability. It's our end user usability as well. All of that stuff. You can make people's lives miserable with. By cranking the security up. I love this slide. I love the turn it to 11 sort of approach to security, because when you turn security to 11 and you don't need it, opportunity cost. That's really the word I'm looking for here. Is there's opportunity cost there. Security is overhead. When it comes right down to it, it doesn't move your organization forward. It might keep it. It's like an insurance policy. It might keep it from sliding backwards really quickly, but it won't move your organization forward by itself. And so if we can minimize that, if we can make good, maybe not minimize it, but if we can make good choices about the balance there, what's needed, and not go crazy. That's all I'm saying. Don't go crazy. Use your head. Second thing I like talking about is Bruce Schneier. Not about him per se, but something he said back in the year 2000, that security is a process. It's not a product. It's not a particular tool and all that stuff. And he might say, Bob, you're nuts. You work for a company, VMware, that sells security products. Yeah, and carbon black stuff, great stuff. But it's not, those tools help. But we have to have the right process going on. We have to have the right frame of mind. It's a process to do security. It's a way of thinking about stuff that's happening, and we need to keep that in mind. You know, and we use tools. We use tools to help us. Tools should help us do our jobs. There should be a really good return on investment for the tools. They should help us do more than we could do by hand, do things that we couldn't do by hand, that sort of thing. And so, important points, you know. What are we worried about, too? I like thinking about the threats. And, you know, 2020's got some pretty clear threats in it here, but one of them in the computer security world and information security is ransomware. And I love, by the way, that the official VMware icon for ransomware is a skull. You know, that's actually, it's kind of cool. The ransomware is the boogeyman that we all need to justify making some changes in our environment, adding isolation, thinking about the way we connect to our systems, the way the systems trust each other, that sort of thing. Because ransomware is scary. It uses our users against us. Here, let me turn off there we go. It uses our users against us. Somebody, an admin using their phone, and all these threats. Admin using their phone disappears. You know, now potential breach there. The idea that Microsoft, clearly it's not Microsoft calling somebody, but maybe they're calling an employee in your organization saying, hey, we've detected your computer is slow. Well, duh, they're all a little slow, right? And helping them optimize stuff. And now they've got keystroke loggers and malware on their systems. Penetration testers love the idea of dropping a USB key, and I'm assuming actual bad actors do this as well. USB key in a parking lot, label it beach photos. Some guy will plug it in, hey, I wonder what's on here, and or altruism. Basically, these folks are playing on people's good human nature. We're built to trust. By and large, we're built to trust, and abusing that trust. You see a USB key, maybe we think about it, maybe if that were us, wouldn't we want our data returned to us? So we plug it in and see what's on there. Maybe we can figure out whose it is, that sort of thing. And that's a bad idea. And so this is why we can't have nice things indeed. So, yeah. And so the malware gets installed, takes control of a user account in your AD, and then something like zero logon comes along. A flaw, zero login, if you're not familiar with it, a flaw in Active Directory where you could take an AD user account and promote it to domain admin with very little effort, and game over. Especially if you're using groups in Active Directory to manage authorization. The attacker just adds themselves to the VMware admins group, and they can just log in now, and that's scary. So we'll talk more about that. I mean, we just talked about some of it here, but we'll talk a little bit more about that. The other thing organizations are really worried about is failing audits. It's fun to rip on compliance and say, oh, compliance isn't security. And that's true, but they're related. Two sides of the same coin. Compliance, if it weren't for compliance, a lot of organizations wouldn't have any security whatsoever. And as a consumer, that scares me a little bit, and that's why we have PCI DSS. That's why we have HIPAA. That's why we have those sorts of things as a consumer protection and leveling the playing field so that people that are doing things right or mostly right or whatever they're trying aren't taken advantage of by people that don't care at all. And so compliance, I want to talk just briefly about why why people care about compliance. And one of them, it helps organizations balance security versus their business needs. There's a lot of folks that don't know really where to start with security, and they've got people whispering in their ear, turn it to 11. Oh my goodness. And that's tricky because too little security, it's clear what the problem is there. Too much security, though, can be just as bad. You've got that opportunity cost we were talking about. You're dedicating resources to things that aren't good. You're not making good choices with your resources, and that drags on the business. And so that balance, there's some a compliance framework, NIST 800-53. It's got different levels to it, and it can help an organization kind of figure that out. So that's actually kind of cool. Don't leave right now because you think I'm crazy about compliance or whatever. But I can see both sides of it. Second, it shows that the business is adhering to some of these requirements. These requirements are normalized across an industry. If you want to take payment cards, if you want to take credit cards, here are the rules you have to follow. If you want to run a nuclear power plant, you have to follow NERC-CIP. If you want to run a healthcare facility, if you want to run a hospital, you have to abide by HIPAA, that sort of thing. And then if you do that, if you show that to your auditors, you gain the ability to operate, an ATO, authority to operate. And you can get paid. You can take credit cards. Hey, everyone likes getting paid. So, and that's important. It's business for a reason. You get paid, and then you can continue doing good things. So, anyhow, enough about compliance. The last thing I want to talk about, sort of baseline stuff here, is a CIA triad. Confidentiality, integrity, and availability. Confidentiality is what we always think about as security. It's keeping the bad actors away from our data, keeping our data safe, our systems safe, that sort of thing. But it's a third of the puzzle. Integrity is a big one as well. Integrity, the idea that when I leave data somewhere, I want to come back to it and have it in the state I expect it to be in. I don't want it encrypted. Thank you, ransomware. I don't want it bit rotted all the heck, by a dying disk array, that sort of thing. Security is not just bad actors. It's, also natural events as well. Hardware failures, like I said, bit rot, using RAID 5 as a backup mechanism, which isn't good at all, that sort of thing. Using RAID 5 at this point is a bad idea in general, but I'm not going to get into that right here. Availability, that's the third part. And availability always gets short shrift. It's the idea that our systems should be there when we need them to be, you know. Conversely, if we don't need them, if we're not using them at a certain time, we can do maintenance on them. We can make other choices about what they're up to. And so availability, like I said, availability gets short shrift because it costs money. You know, it's extra parts. And so we'll talk in a little bit about, especially with hardware, about when we should have extra parts, when we shouldn't have extra parts, what to think about there. So you'd think that was starting at the beginning, but now let's start at the beginning of the system design. I should actually relabel this slide. The beginning of a system design, really want to think about who we're designing these infrastructures for. You know, who's going to use these? Why are we building these? These things are not a means unto them or an end unto themselves. We don't just build. Well, I mean, some people. I have built infrastructure just to build infrastructure sometimes, but in general, we're not building this stuff just because it's fun. We're trying to get something done, right? And so we're doing it for an organization. We're doing it for our organization, building an infrastructure to support the organization, support what the users are doing, support all the needs there. We're supporting our customers. An organization that has vSphere infrastructure has other customers, right? A healthcare facility has got patients that come in. Maybe you've got a website. Maybe it's, all of that stuff. But we're supporting them. That's the work that moves the organization forward. And so these infrastructures have to support that. They have to do it securely. They have to do it robustly. And so that's really important. And then the last population, so we're keeping those first two in mind, but the last population here, we often throw ourselves under the bus. As vSphere admins, we don't consider our own well-being. And we'll often make trade-offs or accept trade-offs. Maybe we don't make the trade-off, but we'll often accept trade-offs, and we don't stand up for ourselves around availability and things like that. And it amounts to toil, is the term that the industry term for it. Extra toil, working on systems when we should have automated, waking up in the middle of the night because we didn't have enough capacity to deal with a hardware fault automatically, that sort of stuff. And it just wears. And so we need to be cognizant of that. And there's policy decisions there, especially with things like certificate management. I talk about this all the time with folks about certificate management in VMware, replacing certificates with custom certificates. I'm going to do a talk on this. Come back, check back with our YouTube channel. I've got a whole talk on this that I'm going to put up in December of 2020 here, and subscribe to the channel so that you get notified when it's put up there. But it's my biggest talk ever. It's 90 slides, and most of them are questions and answers. But one of the big themes in there is use the automation. Don't, just because you replace certificates a certain way back in the late 90s doesn't mean it's a good idea anymore. And so this is what I mean by standing up. vSphere admins need to stand up for themselves a little bit. They've got a lot of things going on, a lot of different pressures. And so adding an arbitrary one is just a bad idea. So my soapbox, I'll get off of it, but that's my thing. vSphere admins are definitely a population. The people that run the infrastructure are definitely somebody we should be designing for. So what else do we need to consider? There's two things that aren't on this list, the two biggest things on the next slide, but budget and staff time, duh. We all know about that, no problem. Time to implement, well, yeah, maybe you'll make some different decisions about what to buy, and maybe you'll go for an engineered solution, VMware Cloud Foundation, VxRail. I've been a Dell guy for a long time. I spent 23 years on enterprise IT, and I was a Dell customer, so I know their product line pretty well. Not to slight HP or Lenovo or Hitachi or anybody else. But, going for a prepackaged solution, an engineered solution, great idea. Just make sure that it's got the security and compliance stuff that you need out of it, because a lot of those things are very prescriptive, and you can't retrofit security onto those things as easily as if you built it yourself. And so just make sure you know what you're getting into. But they can help with time to implementation. Regulatory requirements, we talked about that. Compliance, that sort of stuff, that'll play in. Read the compliance regs before you start a system design. Space, power, cooling, clearly whatever you buy needs to fit into the slots in your data center, that sort of thing. But not as easy as it might seem, not as straightforward as it might seem. You've got some options there, but the other thing, the last thing here is people stuff, battling business units, cylinders of excellence. I mean, silos, not invented here. Not invented here is a really interesting thing, because somebody might like your ideas. Somebody might like your system design, but they're jealous because they didn't think of it. You thought of it first and they didn't think of it. Or maybe they thought of it, but they didn't act on it. It's that perspiration versus inspiration sort of thing. And they didn't act on it. And now they're jealous that you did. And they're going to block you, and it's a people problem, and you got to find a way around it. There's not a good solution to that. There's not a technical solution to people problems, honestly. Inertia, just, well, that's not the way we do things around here, Bob. I've heard that a lot in my life. And yeah, with ransomware, again, use the boogeyman of ransomware to say, well, ransomware didn't exist back when you were inventing your policy. We need to adapt a little bit. We need to meet the new challenges that we have. People, what are you going to do? But the two biggest things that you should ask when you're doing a system design, RTO and RPO, what are they? And in a lot of cases in your organization, you'll say, hey, what RTO are we aiming for? What RPO are you? And people cock their head sideways and go, huh? What are you talking about? RTO, recovery time objective. Recovery time objective. How long can the system be down? How much downtime can the organization tolerate? In their systems. 4 hours, 8 hours. Generally, when you ask, if people haven't thought about it before, they're going to say, well, we can't have any downtime. And then you're going to say, well, we're going to need like $1 billion to do to buy the equipment and the services and all that stuff. We need to be up like that. And they're going to have a small heart attack and fall over, and you'll revive them, and then you can have a conversation about the 5 nines versus 4 nines versus 3 nines, that sort of thing. What do you really need? What do you really need for uptime? Well, you'll get some realistic answers there. So what's RPO? RPO is recovery point objective. How much data can you lose if the building blows up, if there's a mega disaster and all your data is gone, everything's gone? How much data are you willing to lose as an organization? Again, you're going to ask and they're going to go, oh, we can't lose any data, and then you're going to say, well, I'm going to need another $1 billion. And they're going to say, hey, I've heard this one before. I'm not going to have a heart attack this time. And then you can have a conversation about that too. And the nice thing about vSphere is it can be flexible based on workloads. You can have some workloads that have RTOs and RPOs that are drastically different than other ones, and every organization has got that. Not all of your systems need to be recovered immediately if there's an outage, that sort of thing. Not all of your systems need synchronous mirroring to an alternate site. Synchronous mirroring is expensive, especially at scale. The asynchronous stuff might be just fine. Every 4 hours, just make a copy of it. It'll be okay. But that's a conversation you really, really need to have before you start a system design, before you're looking at anything. And it's a conversation that partners should be having with you. If you're engaging a partner, if you're engaging professional services, they should be asking these questions, because these are big design points and they will factor in everywhere in the design. You can go back to, well, we need a certain RPO, we need a certain RTO, that sort of thing. And so, yeah, the other thing that I really like doing in a system design, especially at the infrastructure level, is the idea of loose coupling. I started out life kind of as a programmer, computer science. I did some Windows programming professionally, and I've gotten over it. Thank you, though. Thanks for asking. Yeah, but the loose coupling. I read a book back in the day, a programming book, a Microsoft programming book. Oh my goodness, you know, Code Complete. Steve McConnell. Love this book. Pages 80 and 81 are gold, absolute gold. And the desirable characteristics of a design. Minimal complexity. Who doesn't want minimal complexity in an infrastructure design? Ease of maintenance. Duh, we want that. You should aim for that. Loose coupling. I love loose coupling. Extensibility, reusability, high fan-in. The flip side, I don't want to, I'm a content creator too. I don't want to spoil all of his stuff here. Definitely find a copy of this book. Pick it up. You can pick it up used on Amazon. You can pick it up new on Amazon. There's PDFs of it, that sort of thing. But loose coupling is what I'm after here. Loose coupling means designing so that you hold connections among different parts of an infrastructure, of a system, to a minimum. Using the principles of good abstraction. We like abstraction, right? We're a virtualization company. As few interconnections as possible. Minimal connectedness minimizes work during integration, testing, and maintenance. That's absolutely true. And we see this all the time. We see people ask for a single pane of glass. We see people installing vSphere plugins into the vSphere client, plugins into the client. One, is that a good idea from an isolation perspective? Probably not. Like you've got security connections between things that maybe shouldn't have it, especially backup programs. You don't want your backup systems at all connected to anything production. You want them, if there's ransomware, and you don't want the ransomware folks, the bad actors, getting to your backup systems at all. And you want those as protected as possible. The air-gapped on their own authentication. I've got a lot of respect for Veeam. I'm just using them as an example. Other folks might have this, but their security guides, their implementation guides actually specify that they shouldn't be attached to Active Directory. They shouldn't be attached to the same sort of things for security reasons. A lot of respect for that. That's a great idea. And anytime you connect systems together, you have to make sure that they all work together if you're going to make a change. And that's just friction you don't want at this point. How do you patch? Well, if you're going to patch, if you got all this stuff connected to each other and you're going to patch one thing, you got to check everything. How many months is that going to take? And attackers love change freezes. Attackers love that sort of stuff because it means you're not patching. Ransomware, this is why we hear ransomware stories in the news, is because people have got all this stuff connected and they've just got too much stuff to deal with for testing and integration. Don't tie it together in the first place. Security is a process. So all of the stuff is a process. Think about what you're doing and how it might negatively impact your ability to be agile. Try to avoid the single panes of glass because, as a friend of mine puts it, it's a single glass of pain more often than not. I love that, single glass of pain. There wasn't a good stock image for single glass of pain. There was like broken wine glasses and stuff like that. But this one, I like this one. Try not to tie stuff together like that. Your permission models get better, all that. Question everything. We are in the process of questioning everything, but DNS. How are you getting your DNS? I ran an infrastructure, VMware infrastructure at one point that was generally regarded as so reliable that our DNS administrators didn't think twice about moving our authoritative name servers into it, which was great until we had a power outage. And then we discovered that our authoritative name servers were inside an environment that needed the authoritative name servers to work in order to boot. Oops. And, think about that. Where are you getting your DNS from? Do you trust them? How often do they patch? Do you maybe do your own? Something that I used to do is to avoid dependencies. I used to have a single host in a data center that the single host would have a copy of an ADDC on it. It'd have a DNS resolver, a Linux-based DNS resolver. It'd have a copy of the KMS. It'd actually have a copy of, it'd have a little SMTP server too, so it could send out warnings and messages and things. That was really helpful for eliminating dependencies. It also meant that I could run my own Active Directories and things like that and gain some isolation from the main organization. NTP, same way. NTP is very important. Where are you getting your NTP from? You getting it from the internet? You getting it from a local source? Mix and match. Diversity is a good thing. Well, arguably all the way around, but diversity in sources, time sources, and things like that is really cool as well. So for a couple $100, you can get little devices to put on your network that do NTP and PTP now too. We support that, and those are pretty cool. KMS, if you're doing encryption, key management systems, a key provider, you want that to be as reliable as DNS, because if you're the idea is that you can't decrypt something if you don't have the keys for it. Well, you don't want to be the person without the keys to your own data, right? Oops. It's like losing your keys to your car, and not a good idea. Not a good idea. Enhanced link mode, stretched vSAN, love these tools. They're wonderful, but I'm going to put it to you this way. If you've got a primary site and a backup site, site A and site B, should you maybe you've got vCenters at both sites, should you tie them together with stretched vSAN or enhanced link mode? Because here's the deal. When you do that, you don't have isolation anymore. Your failover site might be subject to bugs and problems coming from the primary site. An example from my own life. I'm full of examples. I like the demotivator posters. The demotivator posters are, if you haven't seen them, they're great. They're parodies of the motivational posters. My favorite one of my favorite ones, is the Lighthouse one that says, sometimes your life just serves as a warning to others. I feel that way sometimes. It's speaking directly to me. But I deployed vSphere 6.7 into production, a new environment. So it wasn't as risky as it's starting to seem, but brand new environment, built out a new 6.7 environment with the GA code 2 days after it GA'd. And that's fine. You should be able to do that. But turns out there was a bug. Not that VMware, we ever have bugs in our code, but should we have a bug in perhaps the customer experience improvement program that would write something malicious, not malicious, that's not the right word, write something malformed to the LDAP servers that are part of the platform services controller. And then you've got linked mode. You've got a couple of PSCs in each site, and they replicate with each other, and now they've copied that malformed thing to all of the other ones, and now vCenter is dying in both of your sites. Is that a good idea? Yeah, that really shone a light on the idea of isolation for me. Really illustrated keeping them apart. So I really urge you to think about, when you're doing this, especially with a DR site, think about the connections between them. Don't create connections between your primary site and your DR site that aren't loosely coupled. ELM is not a loose coupling. Stretched vSAN is not a loose coupling. Try to keep them as separate as possible, because if you have a problem at one site, you need to be able to fail over, right? Logging. An interesting thing about logging is running a syslog server. Your syslog servers, your log servers should be outside of the environment that they're collecting logs for. You get hit with ransomware and somebody encrypts your log server. Now you're down a forensic tool. Logs are super important. I used to run, in my production environments, I'd run 2 sets of log servers. I'd send logs to both of them. Actually, the 2 different sites, primary site, backup site. And I'd send logs to both. That way I could actually patch the log systems. I was using Log Insight, vRealize Log Insight. I could patch them. I could patch one, and I'd still be collecting logs at the other side. So if there was a breach or something wrong right at that moment, I still had a tool to be able to do that. Just keep that in mind as well. That's a lesson hard learned. Speaking of hardware, let's talk about that a little bit. People, process, and things. Those are, three big categories. We'll kind of whip through this. TPM 2.0. If you're buying new hardware, put a trusted platform module in it. TPM 2.0. If you're not putting a TPM in it, all your desktops have TPMs in them. I think it's grossly something. I don't want to say negligent because I think it's awful that you can buy a server that doesn't have a TPM in it. Put a TPM in it. We're doing a ton of great stuff with TPMs moving forward as well. I guess this is the roadmap part that I warned you about. Put TPMs in. They're $40 a server. Put them in. Turn them on. Live it, love it, learn it. Do it. You can retrofit TPMs into pretty much anything that's been built in the last 10 years. But why? When you're buying new hardware, just put them in and just move forward there. CPU vulnerabilities. There are some clear choices about CPU vendors when it comes to CPU vulnerabilities, and I'll just leave it at that. VSGX versus SEVES. Both ways to establish a trusted execution environment for VMware or for applications in general. For VMs, VSGX pins a workload to a particular host. You can't even cold vMotion it. It's stuck on that host. It's attested into that host, and it's there, and it's end of story. SEVES, more flexible. You still can't vMotion warm while the VM is up, but you can cold, and there's some great use cases. VSGX has got more support for the technology out there right now. SEVES, the upcoming Photon 4.0 releases will have the first commercial SEVES support in it. Most operating systems support SEV, Secure Encrypted Virtualization, which protects data in memory, but it doesn't protect it in the CPU. The ES is protecting it protecting the state in the CPU as well, which is really important, especially for CPU vulnerabilities. And then I was talking about, I've been talking about loose coupling. I've been talking about all this stuff. The ROI of additional tools you install. Do you need OpenManage installed on ESXi directly? Or can you just interact with the iDRACs on your PowerEdge servers through their out-of-band network connection? Do you really need that VIB that sets the name in the LCD panel of the PowerEdge based on what the ESXi host name is? Probably not, Spoiler alert, you probably don't need that. And it's just another it's just another thing to worry about. Another thing to have to audit, another thing that could go wrong. If you can get away with not having it, get rid of it. UEFI Secure Boot. Turn it on. Live it, love it, learn it. Same sort of thing. Do it on your VMs, on your template VMs. Do it on, if you're building any new servers, turn it on there. Secure Boot. Also a great argument, by the way, for patching, because Secure Boot, at boot, it will check everything for malware. It'll check everything during the boot process to make sure that it's all working fine, it's cryptographically sound, it's signed by the right keys from Microsoft, from VMware, from Red Hat, from whoever your operating system is. And if it detects something wrong, it'll stop the boot process. And you say, oh, well, that sucks. You don't want that. But you don't want to run... If there's something wrong, you don't want it stealing your data, and so turn it on. It's also a big compliance checkbox at this point, so turn it on. EVC, Enhanced vMotion Compatibility, future-proofing your cluster. If you're building a new cluster, turn it on. A lot of people say, oh, it's a performance problem. It's not. Most enterprise software doesn't really care about what it's masking out. And the thing is that, you're going to care about this in about 3 years when you're going to want to expand your cluster. And you can't get the old CPUs, or you don't want to buy the old CPUs. You want to buy new stuff. And then all of a sudden you're going to discover that you can't vMotion between them because the CPU families are different. If you have EVC turned on, that's not a problem. And if you do run into something that needs... So EVC works by masking out CPU instructions that are different between the families. And if you run into something, a workload that actually needs something it masks out, per VM EVC, it lets you fix it. You can actually set... you can use that tool to set, or use that setting, rather, to set a VM to whatever CPU family you want, basically. So no problems there. But it's flexibility. The payoff, again, the payoff is not right now. The payoff's in 3 years. And so you're looking down the road. That's part of the process here. That's part of this the thinking securely process. DRS, turn it on. Let the machines manage their own workloads. HA, you don't want to get a call in the middle of the night because everything's down. Turn it on. Tell your operations center, don't call me unless everything's down. And the nice thing about patching frequently, rebooting, not only do you get to exercise secure boot and things like that, but you also, if you start patching more frequently, patching your workloads more frequently, people work out the boot process so that all the apps come back up automatically. And that's really nice. So HA fires because something went wrong, and stuff goes wrong. By the time you log in, everything's running again, and it's nice. Something to think about. vSphere Trust Authority, that was released in vSphere 7, and it aims to create a hardware root of trust, a separate cluster that takes all the attestation, all the secure boot, TPM, hardware checking, configuration checking, and it moves that off into a separate cluster that the idea is that it's only a few super trusted admins that have access to it. And it's that cluster then gatekeeps for KMS, the KMS systems. So if a host isn't trustworthy, doesn't pass the attestation process, then it doesn't get access to crypto keys and can't decrypt our secrets, that sort of thing. And trying to enforce some rules in the clusters, and that's really important. So great technology there, very foundational, and it's coming along here as we release new updates to vSphere 7. Then last, people. Expandability, was mentioning that. When I used to buy lots of servers, I get a quote from Dell. I'll just use them as an example. No, I guess it's sort of familiarity breeds contempt, but everyone's like this. And I think it's just the Intel sizing stuff that was the issue. But the SEs would always fill everything up. I'd ask them for a box with a certain amount of RAM, and they'd fill all the DIMM sockets. And and I asked them once in a while, like, what are you worried about, electrons leaking out or something? They'll spill all over the data center floor. Don't fill them up if you can help it. Don't fill all the slots, because in a pinch, it's way easier and faster to get a bunch more RAM that you can just slam in. I mean, it sucks to go out in the data center and spend a day, putting RAM in that, but it's a heck of a lot faster than having to install new equipment, building that all out and stuff. And so leave yourself some options in the hardware space. Don't fill all the drive bays. Leave yourself a couple of open drive bays, that for vSAN, for example, that if you're starting to run out of space, you can just put some drives in. In fact, I used to pull some drives out of hosts. I'd actually take a Sharpie and write the service tag on the top of them, so that I knew if they failed, I knew where the warranty was coming from. But we just keep them in reserve. So if we started running out of space, we'd just go out and add some drives to it. No problem, Just, again, I'm throwing ideas out here, things to think about. Dependencies, we talked about that. Don't watch your dependencies. And then, the easiest thing to secure is the thing that doesn't exist. If you can get rid of stuff, if you can really think about what don't you need in your system design? What tools, those free tools from vendors, they're free like a puppy. They actually cost you money in staff time and opportunity cost. And, get rid of them. The thing that you don't have to secure them then if you don't have them around. One of my favorite quotes, actually, Mark Twain has got a great quote like this too. It's, I didn't have time to write you a short letter, so I wrote you a long letter. That's the Mark Twain one. But perfection is achieved not when there's nothing more to add, but when there's nothing left to take away. And I really like that from a system design perspective. Lean and mean. Lean and mean. So we're getting along here in time. I'll pick it up. Let's talk about isolation. The 2020, all about isolation, and ransomware is forcing our hand here as well. VLANs, firewalls, separation of clusters and workloads, and that's classic stuff. That's table stakes. We know about that. No problem. If you don't know about VLANs, live them, love them, learn them. That's probably the wrong order I've been saying there, but learn them, live them. Yeah, I don't know. Anyhow, Don't mix authorization and authentication if you can help it. Authentication to Active Directory is great. You know, you can do single sign-on and MFA and all that stuff, but maybe think about using a vSphere SSO group instead of an Active Directory group to control who gets to log in to vCenter. Why do that? Well, if an attacker gets into your corporate Active Directory, they can just add themselves to that group. In fact, the first time I presented this was at VMworld a couple of years ago, and I had a guy come up to me after the talk and said, hey, actually, we've got folks that just add themselves to the AD group, and they log in as administrators into vSphere when they want to change something. They don't go through the change control process. And I'm like, oh, that's even, on one hand, that's even worse, you know, like so just think about that. You know, SSO groups, you still have to manage them, but if somebody leaves, you can still lock the corporate account. There's still protections there, but an attacker to break into vSphere then would need to compromise a specific account. They'd need to reset the password on it, and then when that admin actually tries to log in, their password's not going to work, and they're going to start having questions, and that's exactly what you want. You know, you want to detect these folks. And if you've ever read the book Cuckoo's Egg by Clifford Stoll, it's an old book, another great book to pick up. You know, it's about, he found an accounting error on one of his VAXs or something like that at Berkeley. And it led to a international hacking ring, crime ring, all this stuff. And so, you know, maybe you're not Clifford Stoll, but, you know, being able to notice problems like that is important. Does everyone need console access? So consoles are kind of an interesting problem right now. That not that VMware has any problems, but the architecture of them is a little hairy because to get a console connection, you have to basically, the workstation that you're getting the console connection has to be able to get to the ESXi hosts, the management interfaces of them. And that's a little scary from an isolation perspective. I ask people, did you know, back in the days of physical servers, did you give app admins and everyone access to the consoles in the data center? The answer, by and large, is no. You didn't let everyone just waltz into the data center and do their thing. You forced them to use RDP and all that stuff, which is a great way to do it. You know, so let's go back to that a little bit. In lieu of a better solution right now, and we're working on it, you know, maybe think about curtailing console access to just people that you know, and think about how to secure that too. Maybe you put a VPN, maybe you have a walled garden around your management interfaces, and maybe you use a VPN. The idea of a privileged access workstation, that sort of thing, the pause thing that AD has, you know, that model has got a lot of traction in a lot of spaces. Maybe it's something to think about here as well. And then hardware backdoors, actually those ILOs, those iDRACs, all that stuff, they have the ability to create a virtual network interface and present that to ESXi. You do that, it seems like a good idea at the time, but you're creating a backdoor. You know, you're bridging two different security domains together in a way that, you know, how much auditing is on these hardware controllers, how much logging is. I'm a little skeptical of it, and that's, you know, you need to be skeptical too. And so when you see the USB NIC thing, and by default it's on, turn it off, set it to off. You can do what you want, honestly, do what you want, but that's what I would do. Isolate your hardware management. So the VVD, the VMware Validated Design, is pretty prescriptive about using different VLANs for things. It doesn't talk about hardware because, you know, we're not a hardware company, you know, and so I kind of disagree with that. I get why we do it, but, you know, put your hardware management, put your ILOs, your iDRACs, and all that stuff on their own VLAN. Keep them separate, and put vMotion on its own VLAN, put vSAN on its own VLAN. Hypervisor management, the only stuff that should be on there, your hypervisor management stuff should only be the stuff that you need, should only be things that you need to manage the vSphere environment. You can put vCenter in there. I always liked putting vCenter in there so that if there was a firewall problem, it all still worked. It was just walled off differently. Don't put other stuff in there. Don't put monitoring systems in there. Don't put your backup systems in there. You know, you need isolation from those things as well. You know, don't put AD in there. unless you really know what you're doing. Keep it separated. The core of your infrastructure needs to have its own walls and its own perimeter guards and all that stuff. And so I urge you to really think about that, and absolutely don't put any workloads in there. Workloads, applications, scary stuff, and if there's a breach, you don't want that stuff logically anywhere near your management interfaces. Using multiple NICs. Here, I'm just going to skip forward here. I had put this in. It doesn't make a whole lot of sense in this talk anymore, but the idea of having multiple NICs, having one NIC, do everything versus having two NICs, probably a good idea. Split them up. You can put vSAN on the second port of everything, and put all your management on and VMs and all that stuff on the first port of everything. To two top of rack switches. I always liked LACP. I know in some cases you can't do it. NSX, you can't do it, and that. But LACP was nice for me because it was fast failover, and that meant I could patch my top of rack switches as well, and that's really important. To make sure that everything in your environment is patched. And then have a separate connection to an iDRAC or something, so that you can actually query the iDRAC with SNMP. I used to use some SNMP polling tools. Observium was what I used to just catch hardware faults in that. And then I didn't install any of the open managed software. It was easier. Last thing, availability. We don't have much to go here, but availability, very important. I'm not going to harp on patching. I'm just going to say, if you can't patch during business hours, and to a lot of organizations, patching during business hours, it's like, what are you thinking, Bob? Like, oh my goodness, why would you even suggest that? Well, one, your vSphere admins are awake, and that's important. They're not making human errors because they're sleepy and things like that. Two, if you can't patch during business hours, how are you going to survive a real outage? You lose a server, maybe a DIM dies in it or something like that, or all kinds of stuff happens. And if you can't tolerate that, how's your business going to run? How's your business going to operate through that? Because if you build availability into these systems, then instead of everyone being down, all that lost staff time, all that, you can just limp through it. It also means that you don't have to meet a service person. Maybe you bought 4-hour response on your servers, but what's the cost of that 4-hour response versus buying an extra server? And if you bought the extra server, maybe you could just wait for the next day delivery, and then it's sitting on your desk when you got in. That was actually the way I did it. I just did next day service on all of my stuff. Or even if I had 4 hours, I would opt out of the 4-hour thing. And because it would show up, the service person would show up at 6 p.m., 7 p.m. I don't want to be at work at that time. Not that anybody's there now, but you don't want to be messing around at that time. You want to be home with your family. And so, just let it come in, let the logistics people set it on your desk, and then you can fix it on your own terms. Again, something to think about. But this is something that I did to great success, and I really enjoyed it, and my team enjoyed it because, again, we could do it on our own terms. We had the capacity and the ability to tolerate a certain number of failures, and so we used them. We leaned into that. Some things to think about. Are you monitoring your capacity, especially for DR sites? It's really easy to overwhelm a DR site and not know it, because especially if you're using old hardware at your DR site, and the performance characteristics aren't the same. At the very least, count up your RAM. CPU is fungible. You can deal with that, but RAM's a hard limit. Make sure that your RAM totals in your primary site are feasible for the alternate site as well. Are you patching hardware firmware? That's really important. Intel advisories coming out. Their management engine has got big faults in it, or big vulnerabilities. There were some just recently. Think about how you're patching that. Are you doing that? On the Dell side of things, I've got the rack ADM command. I've just got a script that you can ask it to just check firmware from a repository. And you can stage it for the next reboot. And so just do that. Stage it for the next reboot, and then the next time you patch ESXi, You go through and patch vSphere, it'll just patch the firmware at the same time. It's actually, I really like that. That's how I do my lab now, how I did all of my stuff in the past. Nested environments are great for testing. No test environments like production, but just installing it will give you a hint whether you need to know what the password is, or the administrator at vSphere.local password. That's really important. It just gives you a sense of, the easy stuff is out of the way, and you can feel a little bit more prepared. The nice thing about a nested environment, it's how the hands-on labs do all their stuff. You can run ESXi in there, you can run vSAN, all that stuff. And then what you can do is you can shut it down and you can snapshot it. So if you want to see what happens when you completely hose vSAN or whatever, great, and then just revert the snapshot, no big deal. Staged rollouts are really important. You do one host, you do your test environment, then you do one host, then you do 5 hosts, then you do 15 hosts, then you do 50 hosts. Same with desktops, all that stuff. And you just keep increasing and increasing the size of the batch until you're done. And hopefully you catch any problems early enough before you get to the 1,000 machine batches and that. Please always update vCenter Server first. It should go without saying, but we still need to say it. We're also working on that. I'm to the end. I'm sure you're brain dead by now, and you're not brain dead. Your brain is full, and this has been a lot to think about. And I appreciate you listening. Just to recap a little bit, loose coupling, you've heard me say that about 1 million times. Less is more. That's, I think, the first time I've said that particular cliche. But yeah, it's important. Try to get rid of as much stuff as you can. The best thing to patch is the thing that doesn't exist. RTO and RPO, the 2 biggest design points you've never actually used in a design before. Ask them. It's fun to ask people about them. Ask them and see what happens. Sometimes you'll get a response too. You'll find people have answers, and it's interesting. Separation and isolation, big keys. Keep your management interfaces as separate from absolutely everything else as you can. Goes for consoles as well. Question everything. Who do you trust? Why do you trust them? Why do you trust your corporate AD? Why do you trust your corporate NTP servers? Why? Prove that they're trustworthy. And again, if you can't patch, you won't survive a real problem, a real outage or whatever. So think about doing that. I used to patch during business hours all the time. Nobody noticed. vMotion is cool. And vSphere 7 actually rewrote vMotion, so it's even less intrusive now. I've been optimized for faster networks, for a lot of the new workloads and things like that. And I would check that out if I were you. So thank you very much. Thank you for being our customers. Thank you for listening. Subscribe to our YouTube channel, and we've got a new site, Core, C-O-R-E, core.vmware.com, that we're putting a lot of technical information up on. Go and check it out. I really appreciate it. So again, thank you. Take care of yourself, okay?